Calculators, take out your calculators. Here we go. We're gonna continue rectangular approximation method. They named it after a famous mathematician called Riemann, depending on who you talk to. So this LRAM, even though it does stand for left rectangular approximation method, sometimes they call those Riemann sums. Cool or not cool? All right, guys, focus. So LRAM, RRAM, MRAM are examples of Riemann sums. And relax. What we did on yesterday, it was where the delta x's were equal for all of the rectangles. So we had equal width of all the rectangles. They don't have to be equal width. This is not tested on AP, but guess what? It comes out on UH. It's the same principles. It's just a little different. So let's talk about what we mean. Compute the lower, notice it says the word lower, Riemann sum for the given function, f of x equals x squared over the interval -1 to 1. And here are the partitions. You still have, let me see, how many? 1, 2, 3, 4 rectangles, but they're dictated by the lowest value. So what does that mean? So let's go ahead and draw a grid of x squared, and I'm going to exaggerate my grid. So here's my grid of x squared, exaggerated. Let me fix that guy to be perfect. Good enough. Okay, ready? So here's -1. Here is 1. And let's see, -1/4 is probably like right here. And then half is like bam right here. And then 3/4 is in the middle between half and 1. And there it is. So here are my rectangles. Ready? It says the lower Riemann sums. So lower Riemann sums is lowest point on that curve for that subinterval. So the lowest point between -1 and -1/4 is at -1/4. So this is my rectangle for that. Do you guys see how I did it? I picked the lowest point on that subinterval. And the lowest point on that subinterval, Ms. Wilson, is at -1/4. That makes sense?
But the whole and like -1 to 1 is the whole.
On that whole, So between 1/4, I didn't do a good job of putting this right on the x-axis or right through the origin. Between -1/4, so check it out, Wilson. Between -1/4 and half, what x value do I have the smallest y value? At 0, perfect. So between -1/4 and a half, you don't have a rectangle. See how the difference between left Riemann sum and lower Riemann sum? And then between a half and 3/4, this one looks like left, but the lowest value happens at half, so it looks like that. And then between 3/4 and 1, the lowest value happens at 3/4, so it looks like that. Does that make sense? This is called lower, what is this called? Lower Riemann sum. So how do you calculate this? Check it out. This is how you calculate this. What is the width of that rectangle? Be careful. We're just doing I got you. Remember, we're just doing area. Area is not negative because I'm above the x-axis. There is such a thing as signed area, but we're not there yet. So 3/4 times, and how do I find the height? -1/4 squared. Does everyone see how I got that? Because it's x squared that is dictated by. Plus, and I guess you don't have to do this delta x here. The difference between -1/4 and a half is again 3/4, right? -0.25 to 0.75. Oh no, to 0.5. That's 3/4. And then, but my height is 0. I guess you don't need the 0 squared because it's 0. And then plus, what's the gap between 1/2 and 3/4? 1/4, and the height is dictated by 1/2, so I square that. Plus, what's the gap between 3/4 and 1? And then the height is dictated by 3/4. I take the calculator and I add those suckers up. So here's my calculator. And I already forgot the numbers because I can't see them. Can you guys hook me up? What was it? 0.75 times
-1/4 squared.
Okay, so there I am squaring it. Plus 0. Plus, what was that third one? 1/4 times 1/2 squared. I know I'm not being consistent here. Plus 1/4 times 3/4 squared. Push enter, and I got 0.25. Mass fraction enter. I know you guys know that that is 1/4. Oops. 0.25. I mean, I guess I don't need to do this, but there it is, 1/4. And I come here and I circle the 1/4. Yes.
Oh, sorry. So the negative one, did you like not put the point up there because it's like out of like the range? Or like why did you decide to put the point on negative 1/4?
I am totally confused.
Like,
Say it again.
So I think are you doing like
I'm just doing width times height. So you see this gap here?
I know what you're saying. Okay, so we're looking at the red line.
Uh-huh.
Whatever point in between the range of -1 and -4 is the lowest point on the red line.
On the curve, yeah.
okay.
On this curve, y equals x squared.
Okay, and you're doing that for every single
Yes, because the key word is lower. So underline the word lower. This is not tested on the AP, but guess who does test it? UH, and if you're going to a tier 1 university, they're probably going to want you to know it. Like, or do you have to be an expert? No. Could you have figured it out at your university? Yes, because it's not hard to figure out. Lower, the lowest point. So it's something you could have probably figured out on your own, but I wanted to expose you now just in case. Plus, you see it on UH. What's up, miss?
How again did we get the height?
Oh, yeah. So, good question. So the question was, how do we get the height? Notice I'm following y'all's comments because you guys can't hear your questions in here, so now I'm repeating. So I listen, guys. Okay, so how do I get the height of my rectangles? The height is dictated by the curve, the function equals x squared. So if I want to know, like, I'm going to label this rectangle 3. If I want to know the height of rectangle 3, well, notice it's on this curve, on this, and what is this x value? Half. So I plug in half into the x value, and I square it, and that's going to give me my y value of that curve, which is my height. Does that make sense? Perfect. All right. Hit me with more questions, guys. We're good? All right. Go to the next one. Dang, I should have done upper instead of lower. I did 2 lowers back to back. Okay. It says, compute the lower Riemann sum for the given function, f of x equals sine x on the interval 0 to pi. Does everyone know how sine x looks like between 0 and pi? Okay, so let's draw that. I'm going to exaggerate it. Here's my exaggerated sine x. Dang, it's not perfect. That's fine. Yeah, mine's not perfect either. Okay, here we go. I'm going to put my grid. So 0 to pi over 6. Pi over 6 happens pretty quickly, so maybe like right there. And then 3 pi over 4. 3 pi over 4 is in quadrant 2 on the unit circle. So it's halfway between pi over 2 and pi. So it's probably like, bam, right there. And then pi. I have 1, 2, 3, technically. But non-technically you have 2, but that's fine. Cool or not cool? So between 0 and pi, they want lower. Do I have a rectangle between 0 and pi? Yeah, 0 and pi over 6, sorry. I said 0 and pi, pi is way over there. Between 0 and pi over 6, do I have a rectangle? No. Between pi over 6 and 3 pi over 4, I don't know if I drew mine to scale. Which one has the smaller y value? Pi over 6, so go like this. At pi over 6, you have the smallest y value. And then between 3 pi over 4 and pi, where do I have the smallest y value? Pi. So do I have a rectangle? So look how easy they're being. They're being nice. So hope that you get a lower Riemann sum on this, because if you get an upper Riemann sum on these intervals, you have to calculate 3 rectangles. Now I just have to calculate 1 rectangle. So width times height. So I'm going to go 3 pi over 4 minus pi over 6. That's how I get my width. And then the height, this is the sine function. What is sine of pi over 6? Do you guys remember? 1/2. And I'll go ahead and write this for good notes. That was sine of pi over 6, which is the height. Yes, miss?
Why did you go from pi and 6 straight to pi over 4?
Because they told me that my partition, these are my partitions. They told me that I have a partition from 0 to pi over 6. And then they told me that my second partition is from pi over 6 to 3 pi over 4. And my third partition is from 3 pi over 4 to pi. You know what I mean? Oh, yeah. Good question, miss. Keep asking. Hit me. Come on, Espinosa. Focus, miss. Focus. Okay. What question do we got, miss? We're good? For sure. Okay. Yeah, no, make sure you stay focused, miss. All right, here we go. If you don't know how to do common denominator, guys, it's good if we learn it, but if we don't, let's see, what would I have done? I would probably multiply this by 2 over 2, and I would probably multiply this by 3 over 3, so I can get a common denominator of 12. Do you guys see that or no? Okay, and then from there, I would go 9 pi over 12 minus 2 pi over 12 times a half. What's 9 minus 2? So 7 pi over 12 times a half, which, what's 12 times 2? So 24 pi over 24 pi. 7 pi over 24. Chubb, I don't want to do all that. Can you show me another way to do this without all that? Well, if you have a calculator and if they allow you to use a calculator, just go 3/4 minus 1/6 like this. Go 3/4 minus 1/6. Chubb, how come you're not putting the pi? Because the pi is can never be a fraction. Remember, it's irrational. So if you have a CAS, you can put a pi, but if you don't have a CAS, don't. And then just push math fraction enter, and there it is. Put a pi in the numerator. Cool or not cool? Cool. All right. So I just wanted to expose you to that, guys. You do have questions like that on the UH quiz that's coming up. We haven't put it in here yet. Okay, here comes the sigma notation. This is what Piricello was talking about. You guys ready? All right, you ready? We're gonna do the sigma stuff. Okay, so here we go. Have you guys seen this symbol before? It's called sigma. And you do with this is sum. If you're taking AP stats or if you're taking statistics, you probably used it all the time. That's all it means, just to sum. So, excuse me, when it says written in sigma notation, you could write blah blah blah. So this creates this pattern. How does it create it? Well, what it tells you is the j equals 1 is the start, and that means the first term. And then the 6 there is the end. And that means that I'm going to go first term, second term, fourth term, fifth term, sixth term. Sometimes they started at 0. It doesn't matter. And there we go. So here we go. I'm going to rewrite it just so you can see it. J equals 1 to j equals 6 of 1 over j squared. So check it out. I start here at 1. So 1 over 1 squared. Plus, and I keep going, 1 over 2 squared. And I keep going until which one? Until I hit which one? Perfect. Oops, squared. Plus 1 over 4 squared, plus 1 over 5 squared, plus 1 over 6 squared. And then you just go, that's a 1, that is a 4th, that is a 9th, 1/16, 1 over 25, 1 over 36. God damn. Sorry, I heard someone say it. There's also a meme, I think. Damn, or good meme. I'll stop. Okay. And then what is that? This answer, whatever this sum is, you take your calculator. There's actually, you know what? We'll show you a fancy way too, but I just don't want you guys to get used to it. You take your calculator, 1 plus 1/4 plus, what was the next one? 1/9 plus 1/16. Delete. Sorry about that. Plus 1/16 plus 1/25 plus 1/36. Enter. I get that. Did I mess up? No, it's preferred. Oh, you got that? Okay. So 1.491, blah, blah, blah. Let's see. Yeah, if you put parentheses, it's not going to mess it up. As a matter of fact, it's probably preferred. It's probably preferred to do it like this. You know? Let me show you where it is, the summation, and see if we get the same thing. Look how strong this calculator is. Oh, let me clear all this. Math, summation, and I'm going to say you can put any variable here. I'm going to start it at, really we can start it at A, but I'm going to put X just because it's easy. I'm going to put 1, I'm going to put 6 here. And look, I'm just going to put the expression. I'm going to push alpha y equals enter 1 over x squared. And then I push enter. And did we get the same number? Yeah, we did. 5369 divided by 3600.
You just like math, right? It's math and then summation.
Yeah,
Math number 0.
math number 0. Yes.
Oh, I should scroll down.
You go, it's the sum of 1 over x squared from 1 to 6. And start on x equals 1 as the first term, 6 as the last term. Guys, I just want to make sure that you guys know this. It does not have to, okay, Perchula, this applies to you because you're in BC and we're going to be doing series pretty soon. It does not have to start at j equals 1. You could have easily have done this. And you don't even have to call it j. You can call it whatever letter you want. K equals 0 to k equals 5. And look, I could have done it this. I could have done this. And look, I get the same thing, guys. If I start at 0, what's 0 plus 1? 1. So I get this guy. And if I go to the next one, I'm just going down the next term. They're integers. You use integer values. What's 1 plus 1? 2. What's 2 plus 1? What's 3 plus 1? See? So you still get all of them the same, but you got to stop at 5. Do you guys see that? All right, guys. Focus, focus, focus. So see, this is not the only way. There's several ways. Yay or nay? Okay. How do we feel? How do we feel, Paracello? Okay. All right, here we go. Let's practice. Don't use the calculator. Well, don't use the summation feature just yet. All you're doing is practicing. All we're doing is practicing. I equals 1, and I want to go from 1 to 6. So tell me my first term. 1. What's the next term? 2. Keep going. 3, 4, 5. Where do you stop? 6. Yeah, and what do we call this again? This is sigma. It's called sum. And this is why there's another one that's called for product, but we're not there yet. Actually, we'll never get there at the high school level. That's for upper middle of math, but when you get to it, take a picture of it, send it to me, and I'm like, hell yeah, that's cool. Isn't that cool? And hopefully you say yes and not the crying emoji. Okay, here we go. Let's go to the next one. They put the I plus 1 in parentheses. They put I equals 0. So what's my first term? 0 plus 1. You can actually say 1 as well. Plus, the next one's going to be 1 plus 1, which is, well, you know what? We'll write it out. 1 plus 1 plus, what's the next one? 2 plus 1. What's the next one? And, well, yeah, keep going. Where do I stop? And I forgot to answer this one. Not only do you want to expand it, guys, but they also want you to answer it. So let's answer this one. So this one's, we already started this one, so we'll finish this one. 1 plus 2 plus 3 plus 4 plus 5 plus 6. OMG, is this the same as the one in the top? No. Yeah. Yes. I know. 6 plus 5. I guess we can go 1 plus 2. 1 plus 2? 3. 3 plus 3? 6. 6 plus 4? 10. 10 plus 5? 15. 15 plus 6? This is 21. This is 21. How do we feel? All right, let's go to this one here. So here we go. Where do I start at? 3. 3 squared plus 4 squared plus I stop, and then you just write these out. 9 plus 16 plus 25 plus 36 plus 49. And then you add them up. Whatever this adds up to is the answer. Yeah, someone add them up for me and tell me what that is. There. It ends at whatever the term in the top says it, like you end. You call these terms. All this that we're doing are called sequences. Did you guys ever do this in geometry?
Oh, I remember
yeah. All right, here we go. Next one, guys. Notice what it says, 1 over n. This is, sometimes we can put it in the front, sometimes we put it in the back. It doesn't matter. We start at the k equals 1. And I know, like, oh, OMG, I see an n. What do I do there?
I called it low.
Yeah, look, it's relaxed, it's simple. 1 over 1. 1 squared plus 1. That's where I start. You start at 1. Oh, 1 over n. Yeah, 1 over n. It's always 1 over n. Plus 1 over n, 2 squared plus 1. And I'm going to do 3 of them. 1 over n, 3 squared plus 1. Dot, dot, dot means this continues forever. 1 over n squared plus 1. Are we okay? Oh, okay. Don't worry, I haven't done anything crazy. Chav, what's going on? Why is there a 1 over n? This says k equals 1, so I'm only substituting for my k values, and you leave the 1 over n alone, and I'm approaching n. And eventually we're going to write something in the front here, limit as n approaches infinity. We're not there yet, so I just wanted to give you just a little drop of what's going to come pretty soon. The next time we meet, next week, Tuesday, because we meet again tomorrow. How do we feel? Nothing crazy, right? Okay, I want you to observe something. Check it out, Piricello. You see how there's a 1 over n on every single term forever and ever and ever? What can I factor out? A 1 over n. So you can do this. 1 over n, 1 squared plus 1, plus 2 squared plus 1, plus 3 squared plus 1, plus dot, 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 n squared plus 1, close bracket.
So why did you choose to stop at 3 and then do the dot?
Usually when it comes to sequences, you want to see the first 3, or you want to see like a pattern. And when you put 3 of them back to back to back, that usually is definitive for the pattern. Because if, like, let's say the difference between the first term and the next term is 5, then the difference between the second term and the third term is 5, then you can conclude, you can be like, oh, therefore, all of them have a difference of 5 between terms. You know what I mean? And then there's something called geometric series, and there's a whole bunch of, yeah, don't worry, we'll get to it when we get to it. Okay. Are we still okay? I don't know if we should do this one yet. You think we should?
Why not?
Okay, let's start. So, notice there's a little I in the bottom there. So,
Alright, I don't want to do it.
that's fine. Guys, focus. This is kind of like saying height, because it's a y value. And this delta x is like saying width, because it's just a change in x. So this is, you can already kind of see, this is kind of what we're going to be doing, because this is kind of what we are already doing. Width times height, width times height, width times height. And this is the terminology or the symbols that you're going to be using when we're going to be adding x amounts of rectangles or ith amounts of rectangles. Eventually we're going to be approaching infinite rectangles. Does that make sense? So it starts at 1. So I'm going to write f of x1 times delta x plus f of x2, where x2, x1, they're just actual x values, times delta x plus f of x3 times delta x plus dot, 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 f of xn times delta x. And this is kind of like, see, look, height, width, height, width, height, width. And it just keeps going. You add up all those rectangles. But we're not there yet, of course. What's up?
When you have one that's like ongoing, does it matter if you put the plus sign before you put that? Because
Oh, yeah. Put the...
the D, the first one you did it.
Dang, I should have put it plus. Yeah. I put it down here on this one on the sequence, but I didn't put it on the top part, which I should have. I should have put plus and then dot, dot, dot. So... Oh yeah, I would have probably lost a point, especially if it was a BC exam. For you guys won't ever. It's a calculus exam, not a sigma notation exam where, you know, there might be one question, but it won't show like this. It'll probably have a limit in the front. As soon as you put a limit, it now becomes a calculus question. We're not there yet though. Well, you can factor out the delta x just like before, and you know what? I'm gonna put it in the back this time. Parenthesis f of x1 close plus f of x2 close plus f of x3 close plus dot, 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 f of xn close delta x. Let me... Anything crazy, guys? Okay. Let's keep going. And relax, relax. It's just 2 more and we're done. No, we're almost done. We're almost done. Okay. Notice I start. Yeah. Start, guys. But next to merit is a yawn.
The next to merit is a yawn.
Yeah, don't do it. All right. You ready for a cello? Don't freak out. Okay, here we go. I'm gonna start at the first one and I'm gonna go all the way to the 5th one. Cool or not cool? All right. Here we go. Equals F parenthesis 1/2 plus 3, close it. And I'm going to keep going. How many am I going to have? 5. F parenthesis, what do I put? 2 over 2 plus 3, close it. Plus F parenthesis plus 3, close it. Plus F parenthesis. And then finally, F parenthesis. Can we do that? Okay. Let me go ahead and write this number out. This means 3.5, so 3, 6, 7, 7/2. Plus F, 3 plus 1 is 4. Plus, let's see, 3 times 2, 6, 7, 8, 9. F of 9 over 2. That's the same thing as 4.5, right? F of 3, 4, 5. 5. And then F 3, 2, 6, 7, 8, 9, 10, 11. 11 over 2. Cool or not cool? All right, relax. Let's be simple. This F of 7/2 is just like if you were to plug in a 7/2 in there. I'm going to show it one time just to make life simple. I'm going to go -2. This is this one. -2 times 7/2 plus 3. That is this one. Oh, let me change the color. Plus F of 4. No, really, it's simple. It's simple, guys. It really is. I know. It's just cumbersome, but it's not hard. -2 parenthesis 4. Close it. Plus 3. You okay, miss? I know. I'm gonna show you a shortcut right now with a calculator. -2 9/2 plus 3 plus -2 times 5 plus 3, and then one more. -2 times what? 11/2 plus 3. And I didn't change my color here. Okay. I know, that was a lot. I'm just going to find the sum. You know how to do this? All right, guys, focus. I'm going to type this into my Y1. Look, I'm going to show you how to do it. Hopefully you already know the hack because we kind of already started using it. Give me the equation.
-2x plus 3.
Okay. Did everyone get the -2x plus 3 in there? All right, look how you can do it really quick, guys. And we'll see if we can get the same number with the summation equation. Second calculate. Alpha trace y1. And then I open up parenthesis. And what number do I put in here? 7 over 2. Plus alpha trace y1. What was the next one? 4. Plus alpha trace y1. What was the next one? 9 over 2. Plus alpha trace y1. What was that next one? 5. And then the last one, I think this is the last one, right? What was that one?
11 over 2.
And I got a number. Did you guys get the same number I got? Okay, let's see. All right, guys, focus. Let's see if this works. It is. It's going to work. You see how it looks here? Look what you could have done. Make it look exactly like this, except, well, I guess you could even make it, put the K's in the calculator if you wanted to. I'm going to put X so that's faster. Look at this, guys. Math. Which one do I use? And then I'm going to put X. Where did I start it at? 0 or 1? 1, and I went all the way to what? 5. And then look, guys, type in Y1 in here. Alpha trace Y1. Open a parenthesis, and what do they call it? K over 2, or K over. So I'm gonna put the fraction feature, X over 2. Get out of there, plus 3. Look, this is gonna work. Oh, let me close it. I gotta close it. This is gonna work. Push enter, and look at that. Before you start doing shortcuts, guys, make sure you understand what's happening behind the scenes. Just like the doctor example yesterday with area under the curve with heart being pumped. Before you start doing any of this, anyone can do this, guys. Anyone can become a robot and just type in numbers on a calculator. Make sure you know what is happening behind the scenes. Are we clear? Okay, so let's do one more, and then this one we'll just go ahead and just type it into our calculators. So here we go. So tell me what to type in. So on Y1, what do I type in? X minus 4. Cool or not cool? Okay, then I go to my home screen. What do I do?
I forgot how to get to that.
Where do I find anything? Math? 0, the summation. And then what do I put here? X equals 1. And then I go all the way to what? 4. And then what do I put inside the parentheses? Alpha trace Y1. And then what do I do now? Open parenthesis. X plus 3. Is that what they had? 3x plus 3. Close it. And then enter. If you didn't make any mistakes, did you get 26? Can we do that over and over again? Okay, on today's Delta Math, there's a Delta Math today. Relax. It's really short. It says estimated. On today's Delta Math, it's a really short assignment. I think it said in there, 12 minutes. All you're doing is this. Yeah, well, 12 minutes is pretty short. So if you're good with your time, you should be done by 3 o'clock.